Good morning. We're in chapter 2 talking about velocity. A little sample problem in physics right now. And it says this, it says during a race on level ground, so assuming we're like in a track or something like that, Andra runs with an average velocity of 6.02 meters per second to the east. So that's her average velocity. And note that it indicates a direction here too, because a velocity always has a direction with it. What distance does Andra cover in 137 seconds? So they were incredibly nice to you on this problem to give you meters per second and seconds. But here's how I think you should probably do this. This is, of course, going to be the formula that we're going to use for this. And what I always like to do, because these formulas will get bigger, is kind of list out the variables. Okay, that one, delta x, and delta t. So we got to figure out what we know and what we don't know, because we probably know 3 or 2 out of 3 of these. All right, first piece of info here is it says with an average velocity of 6.02 meters per second. So that's, of course, this. So that's 6.02 meters per second. And don't get lazy and leave units off. That's bad. What distance does she cover in 137 seconds? So is that a distance or a time? Well, of course, that's a time. 137 seconds. It could have said 2.5 minutes. It could have been any time interval. But to use this, you need to have meters per second and seconds. So do your converting first. And we actually don't know the distance because it's asking us what distance does she cover? What distance? All right. Get rid of those little ugly marks. So we start with our formula. V average equals delta x over delta t. I like to write that. That way I have a place to put this info. And we just substitute. So this is 6.02 meters per second equals delta x, which we don't know, so we'll put delta x there. Don't put any other variable. Don't put like n. Just put the one that you are trying to find. Delta t would be 137 seconds. All right, now you got to realize something. To find delta x, you multiply these two. And the way I always remember that is to just take a number like 8, and just a little side note here, you can see that 24 equals 3 times 8. So you multiply these two things to get this in a relationship like that. So it's 137 times 6.02. So delta x would equal something around 825. I assume my book probably rounded that meters. And now that's the distance. And then, of course, you would say to the east, because that was the direction that it's running. Remember, this is displacement here. That's displacement, which it's a vector, so it indicates direction. You always have to have a direction associated with it. And the same thing with velocity. It has a direction on it. All right, that's it. Have a good one.